Hi, last time we worked on the parabola and I did some examples on the whiteboard, and one of them, the first one was a little bit shaky because I had trouble erasing. Second one came out better, so we'll be working on that a little bit later. But on Blackboard there are some classwork exercises for you to do, and the solutions are fully worked out. Also on Blackboard is a parabola take-home. It's two problems, which is very similar. They're very similar to the second um, whiteboard video on parabolas. A few things I want to work out with you, which I had modified and updated on the conic section notes. And that's the idea of eccentricity. Eccentricity is how much the curve is different from a circle. So if something gets really squished, the eccentricity is closer to 1 or perhaps even greater than 1, as we'll see later. If a curve, a conic section is more round-like, then its eccentricity is closer to 0. It turns out the eccentricity for a parabola is exactly 1. And it's the ratio of FP over PR in this case. So going to our diagram here, well, we can't really see it in this diagram, but if we go back to the original, it's FP over PR, and that ratio, because in a parabola they're equal, so that ratio is 1. So the eccentricity for a parabola is 1. So that's out of the way. It's going to be different for an ellipse and hyperbola, of course, but at any rate, so far what we know is eccentricity of a circle is 0. 0 looks like a circle, so that's an easy way of remembering it. Eccentricity of a parabola is always 1. It's going to turn out later on that the eccentricity of an ellipse is between 0 and 1, and the eccentricity of a hyperbola is greater than 1, and we'll do that in a good deal of detail in the future. All right, the other issue which I wanted to tackle, finishing up with a parabola, is the length of the latus rectum. So let's just go over that again. The latus rectum is the length of a chord which passes through the focus and is perpendicular to the axis of symmetry of the parabola. So in this case it goes through points A and B. And both points A and B, since the orientation here, they are parallel. It's parallel to the x-axis, so they have the same height as the focus. So the height at point B is P, and what we want to show is that the x value here is P. It's 2P rather. And over here, of course, A would have the coordinates negative 2P, comma P, and we'll see that later on. But at any rate, so what we're going to try and do is find the distance from F to B, and then we're going to double it because of the symmetry issue, and that will give us the length of the latus rectum for a parabola. So we're using the idea that this standard form is x squared equals 4py, and if it goes through point B, then the y is a p. So we end up with x squared equals 4p squared. And if we solve for x, that gives us x is 2p, because x is positive here. So therefore this length here from F to B is 2p, and by symmetry, as we said before, from A to F is also 2p. So there's a little bit of explanation here, but basically we're just looking at the diagram. So the length of the latus rectum for a parabola is 4p. So we're going to stop here. There is a problem set take home on a parabola. It's due on Friday, the end of the week, and then next video that I do will be on ellipse. And for both of these and for the hyperbola as well, there are classwork exercises which are not graded, but they're exercises to help you understand the basics a little bit better, and their solutions are all going to be on Blackboard. But as I said, there will be a short problem set take home for each of those, for parabola, which is already up there, ellipse, which is already up there on YouTube rather, and hyperbola I'll be putting up shortly. So we'll see you soon, and I hope this works out for you.